Organic cocoa bean processing, fermenting, drying, and grinding organic cocoa beans into powder or liquor. The journey of an organic cocoa bean from the farm to cocoa powder or liquor is a meticulous multi-step process that significantly affects the end product's flavor and quality. I will go through each stage of fermentation, drying, and grinding in turn, highlighting the most important parts. The cocoa bean journey, an overview. The process starts by harvesting mature cocoa pods, usually from the Theobroma cacao tree. The fact that the user chose organic means that these beans were produced in accordance with stringent organic farming guidelines, without the use of synthetic fertilizers or pesticides. After harvest, the pods are opened, and the cocoa beans, which are covered in a white sticky pulp, are extracted. Fermentation is the first crucial step in this combination. Step 1. Fermenting the organic cocoa beans. The creation of the distinctive chocolate flavor precursors may be said to depend on fermentation. The beans would just taste bitter and astringent if they weren't properly fermented. This procedure frequently uses conventional methods for organic beans, steering clear of any chemical accelerators. The procedure: stacking or boxing. The beans, which are still covered in the sweet pulp, are often placed in wooden boxes or stacked on banana leaves. Tiered wooden boxes that allow the pulp to drain are frequently used in large-scale organic activities. Microbial activity. Naturally occurring yeasts immediately begin to work on the sugary pulp. The first step is anaerobic, oxygen-free. The yeasts produce heat by converting the sugars into alcohol and carbon dioxide. Acid production and temperature rise. As the alcohol develops, the air gradually enters the bulk, causing the process to become more aerobic with oxygen. Lactic acid bacteria take over, followed by acetic acid bacteria. The acetic acid bacteria transforms the alcohol into acetic acid, vinegar, and crucially, this process produces a lot of heat, which raises the temperature to between 113 and 122 degrees Fahrenheit, 45-50 degrees Celsius. Chemical change and enzyme activation. The heat and penetration of acetic acid into the bean cause the cocoa embryo to die, which prevents germination. Most crucially, the high temperature causes enzymes to become active inside the bean itself. These enzymes begin to break down proteins and complex carbohydrates into peptides and amino acids, the genuine precursors of chocolate flavor. The bean's hue shifts from a light white purple to a deep brown at this point in its life cycle. Turning and duration. The beans are routinely turned, moved, or shoveled from one box to another every 1 to 2 days in order to maintain consistency. This restores oxygen and controls the temperature. Depending on the particular cocoa kind, e.g. Criollo typically ferments faster than